All right, in this video, I'm going to be working some review problems. A lot of it is integral expressed as the limit of the Riemann sum, but then there's some other stuff. This is maybe related to a problem set you have called multiple choice practice dash accompanies review 11. Maybe. We'll see. All right, but this one was just like evidently a particularly challenging multiple choice set in Schoology. So I'm just going to show you how to do all these problems. Number one, they say for a certain continuous function f, the right Riemann sum approximation for integral from 0 to 2 of f of x dx approximated with a Riemann sum and n subintervals. Okay, and the total in terms of n, I guess this is approximately equal. The Riemann sum is exactly equal to 2 times n plus 1 times 3n plus 2, all divided by n squared. And they want to know what's the value of the integral. Well, we know that the actual value of the definite integral is the limit of the Riemann sum as the number of rectangles goes to infinity. N is the number of rectangles. So what we're going to do is we're just going to consider the limit of this as n goes to infinity. And since I've got 2 powers of n on top and 2 on bottom, this is going to be an essentially are the same type scenario, and so it'll be like 6 over 1 is going to be 6. Right. The second one said, which of the following limits is equal to this integral? So what I'm going to do, I'm just going to cook it up kind of the way that we were doing last time, or whenever it was that we were talking about this. X squared dx. I actually like this multiple choice question. This one's somewhat reasonable. Some of these are a little much. All right, for this, what I'm going to do is I'm going to remember that, all right, it pretty much always goes, it's the limit as n goes to infinity of the sum as I runs from 1 to n. It's the limit of the Riemann sum. Then here, we're going to have an f of x, and then there's going to be a dx. Really, it's going to become a delta x. Okay, the delta x is b minus a divided by n. Okay, so 5 minus 2 is 3 over n. Does that help us? Yeah, that eliminates 2 of our answer choices. Okay, and then what we know here, like we're going to just do whatever f does. Well, f takes a number and it squares it. So I'm just going to put that there. And what are the x's that I'm actually squaring? Well, x starts at 2, so it's going to be 2 plus something. And what it ends up being is it ends up being I times delta x, or whatever the indexing letter is, delta x times k, if k is the index, which it does look like that's it on the, so maybe I'll change that to k equals 1. Plus, because the thing that's actually advancing is the x value, as we move to the right in our Riemann sum. So 2 plus 3 over n k. And then we're going to square it because that's what we do to x in this integral. So that's going to be answer choice D. Number 3, just scoot that on over here. Number 3 is going to be which of the following definite integrals is equal to this? And now this one's tricky. I would never put this on one of my tests myself, but if somebody decided that they wanted to, say challenge themselves with a difficult set of practice problems, I'm going to give them that. So k running from 1 up to n, I need to scroll because this image is huge. Sine of, interesting, sine of -1 plus 5k over n multiplied by 5 over n. All right, and then the question is this equal to any or how many of the following integrals? So I'm actually going to call them A, B, and C rather than Roman numeral 1, Roman numeral 2, and Roman numeral 3. This is negative 1 to 4 sine x dx. It sure does fit the pattern, right? We could start this integral at negative 1, have a width of 5. Okay, this is, yes. Feel good about that. And since I feel good about that one, these are now down to A and D. Okay, so that's just something to consider. All right, second one is the integral from 0 to 5 of sine of negative 1 plus x dx. Now that also works because it's got a width of 5, and rather than this being the a value, this is just part of the function, and then it's negative 1 plus, and if we start at 0, 0 plus 5k over n. Okay, I don't know if that explanation makes sense, especially with you, you can't even see me, you're just hearing my voice, but I'm just going to tell you this one works too. Now the third one, and by far the trickiest, is this. 5 times the integral from 0 to 1 of sine of negative 1 plus 5x dx. Now this is a genuinely tough question. So what they're doing here is they're taking this 5 and factoring it out the front. Okay? So if I was to do that, hold on, maybe I'll just rewrite this in orange or something. How I could if I factored out this 5. 5 times the limit of the sum, and I hope you'll forgive my, abuse of notation here. Limit of sine of negative 1, and then I'm going to factor off this 5 times, and then this will be my x, 0 plus, and if the width is now 1, 1 over n, 1 over nk. Right, and this does work, and this would be the sine of negative 1 plus 5x as x ran from 0 to 1. Right, if I factored out the 5. So this one also works for that reason. So I can conclude it's answer choice D, it's 1, 2, and 3, but this is a very difficult question, right? That's fine. Totally understandable if you didn't get that. So number 4, okay, this one is not related to the limit of the Riemann sum at all, but it is one that I have used in the past, and a lot of people have been tricked on. And I don't think I've used it this year, so I think it would be good for you to, view. A tire is leaking air. It's got an initial pressure of 30 psi. The function t equals f of p models the amount of time it takes for the air pressure to reach p psi. So like if you got one of those big tires that goes on an 18-wheeler and you got to fill it up with a bunch of air, put a bunch of pressure in it, it's going to take longer to reach that. But the tricky thing is they say t equals f of p. So what's happening here is we're taking in a p and getting back a t value. That's what the mapping looks like. It takes in a p value and gives you back a t. P is measured in psi. T is measured in what? Hours? Yeah. So remember that the units of f prime are going to be the units of the dependent variable divided by the units of the independent variable. So also you could think about f prime of p is the derivative of t with respect to p, which is going to be units of t divided by units of p. No matter how you want it, this is hours per psi. And we're used to time being the independent variable, so I just didn't want anybody to see that and get it wrong and be confused. All right, the function f is given by f equals log x. The graph of f is shown above. Which of the following limits is equal to the area of the shaded region? Okay, this one is kind of, I don't know if y'all even see this for what it is, but this is kind of like a 2-layer question because nobody ever actually said the word integral anywhere. So what you have to do is, okay, I'm going to just give you a very crude sketch. Say that's 4, that's going to be 1 because it's the graph of y equals log x. This is what they had shaded, right? So that means I need to know that that means the integral, and I know everybody in here knows that right now, this is the integral from 1 to 4 of log of x dx. Okay, but they are not even assuming you know that. So what are we going to do? We know it's a limit of a Riemann sum. The limit as n goes to infinity. Got some kind of index. They're going to use k in this problem, so I can do the same. All right, what does f do? It takes the natural log of something. And what we're starting at 1, so it should be the log of 1 plus something. And then there's going to be a delta x. Delta x is b minus a divided by n. 4 minus 1 is 3 divided by n. And then it's delta x times the index. So I think it's going to be, what is it? It's like, oh, yeah, it's definitely b. Yeah, I see what they did. Even the difference, but there's a huge difference there. All right. And then, okay, the rest of these are all related to the definition of the derivative. So, the limit as x approaches e of x to the 20 minus 3x minus e to the 20 minus 3e divided by x minus e. Well, I need you to remember that the definition of the derivative is f prime of, we'll say a number a, is the limit as x approaches a of f of x minus f of a divided by x minus a. Meaning that this limit is really just code for the derivative of this is my function, f of x, at this is my x value. So what we want is, this is really just, this limit is equal to the derivative with respect to x of x to the 20 minus 3x at the point where x is equal to e. That's going to be 20 times x to the 19 minus 3, where x is e. So that's answer choice B. Right. Hold on just a second. Yes, just hold. All right, number 7 is the antiderivative of 2 to the x with respect to x, which, you know, not that exciting. I think I will. The thing I'll say about this is I showed y'all about this, and I mean, this was the only one I could find in all of the materials that I have that was multiple choice from an actual, like, College Board AP exam or something that had a derivative or antiderivative of a exponential or a log with not the natural base. So what you do is you say that's e to the log 2 times x. Okay, so you divide log of 2, because if this was e to the 10x, you'd have to divide by 10. Okay, then you realize that this thing in the box is just 2 to the x. So that's why it's 1 over log 2 multiplied by 2 to the x, and then add c. That would be answer choice C. All right, now this one I found interesting. Number 8. I think I've seen this problem before, but I haven't used it in a few years. Should be using it. So the limit as h approaches 0, which in general is a pretty good hint that they're talking about a derivative of, I'm not going to write out arc sine, I'm just going to say arc sine of a plus h minus arc sine of a divided by h equals 2. I feel like there's other ways you could solve this. Once you see the answer, maybe you can see a different way of solving this. What I'm going to do is I'm just going to recognize, hey, wait a second. Again, limit as h goes to 0 of f of x plus h minus f of x divided by h is f prime of x. Well, if we replace x with a, that means we're saying that the derivative with respect to x of inverse sine of x at the point where x equals a, that's equal to 2. Well, I have a formula for the derivative of inverse sine of x. That's 1 over the square root of 1 minus x squared, where x is equal to a. So maybe I just should do that right now. Equals 2. Yep. So I'm going to have, really I can just flip both sides and I'll say the square root of 1 minus a squared is equal to a half, meaning 1 minus a squared equals 1/4. If I take 1 and I lose some amount and I have a quarter left, that's because I lost 3/4. So negative a squared equals negative 3/4, meaning a squared is 3/4 and a is plus or minus root 3 over 2. You're only going to see one of those in the answer choices. That's why they said it could be the value. Okay. That's how you did that one. That was very tricky. And most of all, because it required you to remember the derivative of arcsine. But that's a really good way to ask you to remember something. I do also think that this can be viewed in light of the derivative of regular sine using your inverse function derivative rules, but that would be something I'd leave for you to investigate on your own. We can just control that by knowing the derivatives that we are tasked with knowing. All right, here's another really good one because it's another derivative that we just have to know. So I've got the limit as h approaches 0, that means derivative, of tangent of 3, not just 3, but 3 times x plus h, minus the tangent of x all divided by h. Wait, no, tangent of 3x. So that means that the function is tangent of 3x, and I want the derivative of it. So this is just the derivative with respect to x of tangent of 3x. All right. Now, suppose you know the derivative of tangent is secant squared. Good for you. That's very fast. But suppose you're sitting there on the day of the AP exam and you don't know how to take the derivative of tangent of 3x. Okay? I'm going to tell you, well, like there's definitely something you could have done to fix that, and that would have been just know what you need to know. But in the absence of that, the next best thing, I wouldn't recommend doing this, if you think time's going to run short, but if you have extra time, you can always say that sine of 3x divided by cosine of 3x and take the derivative using the quotient and chain rules. It won't be the most fun ever, but it's better than just not knowing, right? So I just wanted to throw that out there. All right, so 3 secant squared, 3x, that's b. Okay. I've got just a couple of more. All right, so number 10. I'm going to say x equals 2e, the limit as h approaches 0 of log of x plus h minus the log of x divided by h. That's equal to the derivative with respect to x of log of x. And we know what that is. That's 1 over x. So when x equals 2e, I'm going to have 1 over 2e. That's answer choice A. Moving on. All right, for number 11, the limit is h approaches 0 of e to the negative 1 minus h? Wait a second. Minus e to the negative 1 all divided by h. Okay, this one is tricky because I think it's... Oh man, I didn't notice this when I copied the problem. So what I think is happening here, anybody that's in here feel free to chime in. I think I've got e to the negative x at x equals 1. Right? Because if I did the limit as x or as h approaches 0 of e to the x plus h, that would be e to the negative 1 plus h. Yeah, that's pretty devious. That's all right. Maybe there's a different way of looking at this, but I'm looking at this as the derivative of e to the negative x at x equals 1. And then maybe, you know, since you've watched this far, I'll show you another trick that might could help you with this. That would be negative e to the negative x, so negative e to the negative 1, which is answer choice B. Maybe you're like, oh, I wouldn't have seen that. And if you can tell that it's one of these, but it's not working for you, you do have another option, right? We do have a way that we dealt with limits this whole year up to this point, right? We use L'Hopital's rule. So I'm going to just kind of take this, slide it right over here, and say, all right, when you plug in h equals 0, I'm going to get e to the negative 1 minus e to the negative 1. That's 0 divided by 0. So I take the derivative with respect to h. Okay, this is a number. Its derivative is going to be 0. And e to the thing is its own derivative, so this equals the limit as h approaches 0 of the derivative of e to the negative 1 minus h is going to be this times negative 1 for the chain rule on h, minus 0, because that's a number, derivative of a number is 0 or 1. And then I let h run towards 0, and I'll have negative e to the negative 1 like I had before, right? So it's all the same. How do you want it? Right? And so I do want to just point out that L'Hopital's rule still applies to these limits. It's just, you know, I want you to be able to recognize that they're talking about a derivative. Okay. And that's going to be all for this video. That was the whole multiple choice practice to accompany review 11.